right. So just to make sure, I think that I only had us do just the odd numbered problems. So I'm going to do some even numbered problems so we get a feel for what this looks like. Let's look at number 4. Well, let's do number 1 first. So on number 1, we've got log base 3 of 2x minus 1 equals 3. And so using some of the properties that we've learned in prior lessons, we're going to raise both sides to the 3 power. So, or in other words, we're going to have 3 as the base on both sides. Now, raising 3 to something that's log base 3 cancels that out. And so on the left, you're left with 2x minus 1. And on the right, you've got 3 to the 3rd power. And I'm going to go ahead and evaluate 3 to the 3rd power as 3 times 3 times 3, which is 27. And then we just solve this like a regular equation. 2x minus 1, I'd add 1 to both sides. And we'll get 2x is equal to 28. And then dividing by 2, x is equal to 14. Now that should be our final answer, but we're going to double check just by briefly going in and substituting back in. So 2 times 14 would be 28, and 28 minus 1 is 27. So the log base 3 of 27 is equals to 3, and that is a true statement, so that works. So let's look at number 4. Number 4, we've got 2 log base 3 of x plus 4 minus log base 3 of 9 is equal to 2. And so we're going to use some of the properties of exponents. We're going to take log base 3 of the quantity x plus 4, and we're going to use this 2 that's out in front. We're going to bring it up here as an exponent 2 minus log base 3 of 9, and that's all equal to 2. And we can go a step further. When you have 2 logarithms with the same base and they're being subtracted, we can rewrite that as log base 3 of x plus 4 quantity squared divided by 9 equals 2. And then we can take both sides, raise them to the power 3. That cancels those, and we're left with x plus 4 squared over 9 is equal to 3 squared, which is also 9. Then I'm going to multiply by 9 to get rid of this 9 down here. And that gives us 81 on the right. Then we're going to expand that x plus 4 squared, so it becomes x squared. 4 times x, 4x doubled is 8x. And 4 squared is 16. Equals 81. Now I want to subtract 81 from both sides. And 16 minus 81 would be negative 65. Equals 0. So then we're looking for two numbers to multiply to give us negative 65 that combine to give us 8, the middle term. And I can see that 65 is divisible by 5. When you divide 65 by 5, you get 13. So I'm going to use those numbers 5 and 13, but to get negative 65, one of them has to be negative, the other one has to be positive. And since 8 is positive, our larger absolute value would have to be positive. So put positive on 13 and negative on 5. And so this factors out to x minus 5 and x plus 13. And so we have two values that would come out to make this true. X equals 5 or x equals negative 13. Now, one of the things that we need to watch for is that you can't have a negative in your logarithm. And so if I put 5 up here, 5 plus 4 is 9, that's fine. It's not a problem. But if I put negative 13 up here, negative 13 plus 4 would be negative 9. And there we have a problem because you can't have a negative. So we cross out negative 13 as an option. And our final answer is x equals 5. Have you looked at this homework before, Brooke? Is there a problem you'd like me to go over? Let me go back and share my screen with you again. Okay, I'm gonna, I'll just choose then. Let's look at number 6. So here we've got log x plus log of x minus 21 equals 2. Now, when you don't have a base, the base is understood to be 10, but they're both the same, so we're good with that. We want to see if we can combine these. And so with this, we'll say, let's see. I have log, since they're being added, let's put a bracket, x times x minus 21, and that's equal to the other side, which is 2. And again, because the base is base 10, we can now raise both sides to 10. Or take 10 raised to both sides. And then that cancels the log, leaving over here, and I'm going to multiply this out. X times x is x squared minus 21x. And then on the other side, it's equal to 100, so I'm going to bring that over as well. Minus 100 equals 0. And once again, we're looking for two numbers that multiply to a negative 100 and combine to negative 21. So I think 5 times 20 is 100, but if I subtract 5 and 20, I get 15, not 21. I think 4 and 25. So if I take 4 times 25 and make the negative on the 25, negative 25 times 4 is negative 100, and negative 25 plus 4 is negative 21. So our numbers, x plus 4 and x minus 25 equals 0. And here x equals negative 4, or here x equals 25. Now, once again, if I put these two values back in, one or more may or may not work. Negative 4 in for the x up here makes it log of negative 4, and that's an error. You can't take the logarithm of a negative number. So there's that domain restriction that we saw in lesson 4. So it doesn't work there. It doesn't matter if it works over here. And it also doesn't work over here because negative 4 minus 21 would be negative 25. So we can cross that out. And then x equals 25. If I take the log of 25 plus the log of 25 minus 21, which would be 4. And so that then alone would be our solution. Let's put this aside for a second, take a look. Some of these that are just like exponential equations to see about how would we solve some of these. look at number 12 here. We've got 5 raised to the x plus 3 power is equal to 30. So I'm going to try to get this x plus 3 out of being in the exponent part of this. So I'm going to take log base 5 of both sides. And that would cancel the 5 here, leaving x plus 3 is equal to the log base 5 of 30 and subtract 3. So x equals log base 5 of 30 minus 3.
Wow.
And then we can use the change of base formula. Log base 5 of 30 is the same as the log of 30 over the log of 5. And then minus 3. And that would be equal to what we already had isolated on the other side, which is x. So then we then put that in our calculator. And here this is x is equal to 2.113. We'll leave this as a 3 minus 3. So x is equal to negative 0.8867. And if I want to know if that works, I would just go back and take that number, put it in here for x. So if I take 5 and raise it to the power of negative 0.8867 plus 3, sorry, putting this in my calculator, it does come out to 30. So that works. All right, Rook, I'm going to let you choose one more. any of these on the screen or any of those off the screen that you think would be good for you to know or your classmates? $17 sounds good. Let's take a look at that. So in 17, the first thing we want to do before we do what we did in the last term, we want to get rid of this -3. So we do that by just adding 3 to both sides. We then get 5 raised to the power 4x minus 7 is equal to 13. And then at this point, we want to take, let me write my 13 a little bit further to the right. So at this point, what we're going to do, we take log base 5 at both sides. We do that to get rid of this 5 here. So that takes care of that 5, and it leaves 4x minus 7 on the left is equal to log base 5 of 13. So just as an aside here, we'll go over here and say log base 5 of 13 is equal to log of 13 over the log of 5. And I'm going to put down my calculator. Bear with me for just a second. Actually, let's pull up our virtual calculator. So here I can type in log of 13, close the parentheses, divide by the log of 5, close the parentheses, enter, and we get 1.5937. 1.5937. So in our equation, we can put 1.5937, 4x minus 7, add 7, give us 4x is equal to 7 plus 1, 8.5937. And divide that by 4. And x then would give us 2.1484. So if I want to check to see does 2.1484 work in here, I can pull up my calculator and put in 5 raised to the power, and here I want to put it all in parentheses, 4, open another set of parentheses, 2.1484 2.1484. Close the parentheses. Minus 7. And then close the other set of parentheses to close that out. And then subtract minus 3. Now I got 9.998. So that's pretty close to 10, which is what it needed to be equal to on the other side. I think I'll leave the others here for you guys to practice. Oh, let's do 19. 19. We're dealing with the power e, and so I want to deal with what does it look like when we're doing that. So e to the 2x minus 2e to the x minus 3 equals 0. And so I want to get that minus 2e to the x. I'm gonna add that to both sides. Minus 2e to the x power over here, minus plus 2e to the x power, canceling it on the left, leaving e to the 2x minus 3 is equal to 2 to the e to the x here. And now, like in the past, there's other problems. We raised it to the we took the log base 5 of both sides because it was 5. Log base e, just as a reminder, log base e is the natural log, and we write that as ln. And so we're going to take the natural log of both sides. And I'm hitting a brick wall here, so I'm going to take a look real quick.
All right, guys. Equals ln of 144. We realize divided by ln 25 minus 1, and then we divide by 5 equals ln 144 minus ln. The answer right here, we should recognize this as one of our factoring binomial equations. So let's just look at the negative 18 and the negative 3 here. So what two numbers multiply to give you negative 18 but add to give you negative 3? Well, we have 6 and 3 and we want it to be -3, so -6. Now the question is, what term goes here? Actually, it's e to the 2x. I'm going to prove that to you now. E to the 2x times e to the 2x. Well, that's e to the 2x squared. Think of this as e to the 2x squared. And what do you guys do with exponent to exponent? We multiply, so we get e to the 4x. Okay, so that's just to prove to you. We get this equals 0. So we have to do each of these separately. E to the 2x minus 6 equals 0. And e to the 2x plus 3 equals 0. And then we solve. E to the 2x equals 6. How do you get rid of the e? Well, let's ln both sides. And then divide by 2. ln 6 over 2. This looks like a good answer. Let's try this one. We get e to the 2x equals -3. Let's ln both sides. So we get 2x equals ln -3. Oh, that can't be. So actually, let's just stop right there. We can't go any further because you can't have an ln of 0 or a negative value. So our only solution is x equals ln 6 all over 2.
Okay, looks like I probably took a different approach here that maybe I shouldn't have taken, but that's all right. Learn from it. So here, let's go back and erase these. And then let's look at see if we can factor this. So -3 and -2. I'm going to use -3 and +1. -3 times +1 is -3, and -3 plus +1 is -2. So that would work for the factoring part. And then on the other part, we'd write e to the x power, because e to the x times e to the x, adding the exponents becomes e to the 2x. So then we'd take each of those and set them equal to 0. E to the x plus 1 equals 0. So e to the x equals -1. And then taking the natural log of both sides, we would get x equals the natural log of -1. And there we can say that's not going to work because you can't take a natural log of a negative number. So on the other side, we get e to the x minus 3 equals 0. You get e to the x equals 3, taking the natural log of both sides. Cancels the e on the left, leaving x is equal to the natural log of 3. And like we have done before here, you can put that in your calculator. Natural log of 3 the natural log, the natural log of 3 equals 1.099. is our approximate value for x. Anywho, I think you'd take a similar approach to 21. You'd want to factor this as a trinomial, saying, okay, well, how would this look? And then you'd go through that similar process. So I'd say, well, what -2 so I'd think of this, the coefficient of this number 3 to the x as being +1. So -2, I'd put +2 and -1. That would give me -2, and then 2 plus -1 is +1, which should be the coefficient of this number here. And so then the values that I would raise this to would be 3 to the x and 3 to the x, and that would be how you factor this, because 3 to the x times 3 to the x, when you multiply like bases, you add the exponents, and x plus x is 2x, so this would be 3 to the 2x power. And so this would be how you'd factor this, and then you'd set each of these equal to 0 and go from there. All right, did you have any other questions, Rook? All right, well, I appreciate you coming to the meeting. I have recorded this, so we'll post it to Canvas under the most recent lesson that we did, 11.5, so that others can take a look at what we've done. I hope that you have a good rest of your day. If you have any issues as you're working through the homework, let me share one final thing with you here. You can reach me at 801-413-3363, and that's a Google Voice number. You can call there, you can text there, and that's really the fastest way to get a hold of me. So if it's not urgent, you can send me a text and I'll get back to you when I can. If it's a little bit more pressing, give me a call. If I'm unable to work with you, I'll let you know when I can work with you as soon as I can. But that's, I think, it for today. Have a good one.